Hey everyone, in this video we're going to look at scatter plots. So scatter plots display two numerical variables. So you can see here we're looking at balls faced and runs scored in a game of cricket. So previously we looked at parallel box plots, back-to-back stem plots and segmented bar charts. They were displaying one categorical variable and one numerical variable. For scatter plots, both variables have to be numerical, so both numerical. Whoops. All right, and this is what we do a regression analysis for. So we don't just draw a scatter plot, we go into a lot more detail. So we're just going to touch the base of scatter plots here, but go into regression analysis a little later. All right, so for this first question, we've got the table above shows the number of runs scored and the number of balls faced by batsmen in a one-day international cricket match. Use a calculator to construct an appropriate scatter plot. Now, when you're doing a scatter plot, you do need to decide which one is your explanatory variable and which one's your response variable. Now, sometimes students think this is, the first one's your X and then you got Y, or your explanatory variable and your response variable. Now, it's not always going to be around that way, so you have to just think about it before you make that assumption. All right, so balls faced. All right, so think of cricket, balls are being bowled, and then you score some runs. It's not going to be the other way around. You don't run and then you get more balls thrown at you or bowled towards you. So EV is your balls faced and your response is runs scored. All right, so it's important to do that because being consistent with how you do things is extremely important, so you don't get confused. Let's just clear everything in here. All right, so I would always suggest put your explanatory variable in list 1 and your response in list 2. You don't have to do that, but it's just going to make things a lot easier if you're consistent. All right, so let's plug these values in. Try to be quick. Try to be quick, but also make sure you don't make any errors. All right, we can't make any errors. 27. So you would kind of expect the more balls that are bowled towards you, the more runs you're going to get. I don't know. I don't play cricket. I don't know how it works, but I'm making that assumption. 10, 2. All right. Always do a double check of the numbers and just make sure they line up. All right, so for your scatter plot, just like with any other plot, we go here, and the first one is scatter. In list 1, we do have our explanatory, so X for the X variable, but also explanatory, and then your response variable in list 2. Now we don't need anything else, so I just made sure that there was nothing in 2 because the previous question I did was parallel box plots. We don't need to refer to the frequency. The mark is just what sort of what you want on your diagram, so square is fine. All right, and there's my parallel box plots. Let's get rid of them. All right, and there's our scatter plot. Now it's just plotting these points. You don't need to put a line in between them. We do that when we look at time series graphs, but for this, yeah, you're just plotting all these points, all 11 points. Now, if you want to know what they are, you can just go to analysis trace and you get your little cursor. So just pressing your arrows will go between them if you need to see which one's which. All right, so there it is. And the point is here. So when X is 6, Y is 2. So where is that point? Down the end, 6, 2. All right, it's just plotting the points. All right, question 6. For which one of the following pairs of variables would it be appropriate to construct a scatter plot? So remember, for a scatter plot, they both have to be numerical. All right, so as soon as I see a categorical, I'm like, bum bum. All right, so eye color, it's categorical. So no, it's not going to be A, and hair color is also categorical. Test score, possibly. It doesn't tell us how it's going to be measured, so I'm assuming it's going to be numerical. And sex is measured as male or female, that's categorical, so it can't be B. Political party preference, so we've got Labor, Liberal or other. No, that's categorical, so we cross that one out. Age in years and blood pressure. Okay, clearly both numerical. Let's just rule out E. We've got height, which is fine, that's numerical, but then we've got sex. So D is our answer. All right, so 2 numerical variables. Can only do a scatter plot with numerical variables. All right, I've just grabbed a couple of questions from chapter 3, just so we can have a little bit more practice with our scatter plots. So in chapter 3, what we end up doing is drawing a scatter plot, but then we do what's called a line of best fit, and we don't do it by sight, we actually work it out. Let me just get to the next page. All right, so for this one, oh, I've got the same one as before. Is that the same data? 29. Oh, it is, but just see, notice that it's around the other way. Oh my gosh, is it exactly the same? Okay, exactly the same data, but notice that the table is just around the other way, and it's actually told us X and Y. That's really weird that they've done that. All right, so instead of us doing that again, I'm going to show you what you can do if you've got them around the other way. So remember this, the Y we put into list 2, and this was list 1. All right. Actually, I don't need to tell you anything because they're going to be already in their lists. We're going to use the calculator to show the equation of the least squares regression line. All right, so we've already done the scatter plot, so we don't need to do that again. All right, so runs was in here, balls faced in here. Now, if we want to do a regression line, just go back to your stats, and we want to go to calc, regression, linear reg, and our X list is list 1, Y list is list 2. Now, later on, we're going to do copy residuals. So if we did that, we want to put it into a different list, but we're not going to bother with that right now. You can also copy the formula if you want to. All right, we're not going to do that either. All right, we're just going to draw, we've got our scatter plot and we're just going to do a regression line. Let's go, okay. All right, so here up the top, we've got the format of the equation, and it is the same as y equals mx plus b. All right, back when you did linear equations starting probably in year 7, maybe 8. With stats though, we tend to do the second one. So a plus bx, it's just around the other way. Don't ask me why. All right, so we can see our a is our constant, which is our y-intercept. So it's negative 2.6, which we can see is written here. And then our b, which is our gradient or slope, which we tend to refer to it in general, is 0.73, which you can see here. Now, we don't tend to write regression equations in terms of x and y. We have to use the variables in the question. So our y variable is runs, so we write runs, whoops, with an n. Runs is equal to negative 2.6 times 0.73 times balls faced. Now just make sure that you always, when you're doing regression, that you don't leave it in x and y. You have to use the variables in the question. All right, let's do a different one. This time, different variables. All right, the table below shows the number of TVs and cars owned per 1,000 people in 6 countries. So it's told us x and y. Again, it's around the other way, so don't get mixed up. Pretty silly variables actually, because I wouldn't say the more cars that are owned, the more TVs there are, and why it wouldn't be the other way around, but it doesn't matter. It's calling number of cars our explanatory, number of TVs our response. And we want to predict the number of TVs from the number of cars, which is the response variable. All right, so it's number of TVs is always your y variable, and it's also told us that's what we want to predict. So your regression equation is y equals, that's what you're predicting. So number of TVs. show that in terms of x and y, the equation of the regression line is. And here we've got significant figures. So let's talk about significant figures here as well, because this is where you would be tested on significant figures. All right, going back, let's clear everything in there. Whoops, must have right-clicked. All right, just quickly putting our values in. Now remember, we put x in list 1. So I'm going to put the bottom row in first. If you did it around the other way, you're going to get the incorrect answer. All right, 550. And then list 2. Okay, so if you want to see the scatter plot, remember go there, this one, list 2, beautiful. And we can go here. The only thing is it's probably, oh no, I thought it was going to have the same regression line on as before. So now we can go to regression, linear reg, list 1, list 2. We don't have to worry about any of this just yet. And here's our equation. So you probably don't need to reset the a plus bx. It's probably saved it from before. And now when we're doing significant figures, we always look for the first non-zero digit. So for a, it's 6. And then we count 3. So 1, 2, 3. So we go 61.2. For our b value, we've got starting with a 0, so we ignore that one. And then we count 3. 1, 2, 3. Now we've got, we have to also round like we would a decimal. So the next number is 5. So we do have to round up. And then because it's a 9, we've got to round up again. So think of it as 29. What's the next number? It's going to be 30. So that's why we get 0.930. All right, rewriting the equation. So we're going to have number of TVs is equal to 61.2 plus 0.930 times the number of cars. Now, the reason, I wanted to do these 2 questions is just so I could show you how to do the scatter plot again. Because scatter plots are pretty easy. It's the regression analysis stuff that follows that is a little bit harder. All right, and that's all. All right, bye guys.